Hello everyone, my name is Bhavya Dakolla. Currently I am pursuing B.Tech 4th year in EC domain at RGKT Basar. Coming to project, I have done my project in embedded system which was offered by Emertxe Information Technologies along with S.Lahari Vishista. My project about washing machine simulation in PICSIM lab by using microcontroller. From this internship, I have learned many things. As of some, they are mentioned in this PPT. In table of contents, introduction to embedded system, embedded C, softwares used, categories of embedded system, components of embedded system, interrupts, project, output. Coming to introduction to embedded system. Embedded system is nothing but it is combination of both hardware and software which gives desired functionality. Example: fridge, micro oven, washing machine, MRI, smartwatch and Wi-Fi modem. So we can define microsystem as a microcontroller based on software driven, reliable, real-time control system. Here some of the examples which are used in our daily life. These are the real-time examples. Embedded C. Embedded C we use C language rather than Python, Java, etc. because C is efficient language and fastest language. In embedded C, we have keywords, data types, conditional statements, operators, arrays, pointers, functions. Coming to keywords. Keywords are nothing but reserved words, also known as identifiers, whose gives meanings and purpose cannot be changed. Here some of the keywords related to C: auto, break, case, char, constant, continue, default, do, double, else, enum, extend, float, for, go to, if. These are the some of reserved keywords. Data types. Data types, it is a attribute that tells a computer how to interpret the value. Data types are classified into three types: primitive type, derived type, user defined type. In primitive, we have char, int, float or double, void. Derived data type. Derived data type further classified into three types: signed, unsigned, long, double. Signed character, signed short, signed int, signed long, unsigned character, unsigned short, unsigned int, unsigned long. User defined data type: array, struct, union, enum. Coming to conditional statements. Conditional statements, we have two types of conditional statements. One is single iteration and another one is multiple iteration. In single iteration, the block of statements can be executed only once. In multiple iteration, the block of statements are executed multiple times. In single iteration, we have if else, if, nested if. In multiple iteration, we have switch. These are the syntaxes of the conditional statements. Then we have operators in C. We have many operators in C. Among them, these are very important operators: unary operator, arithmetic operator, rational operator, logical operator, bitwise operator, assignment operator, ternary or conditional operator. Unary operator, which performs only on single operand. Binary operator, ternary operator, plus, minus, multiplication, division, modulo. These are arithmetic operators. Less than or equals to, greater than or equals to, double equals to, not equals to. These are relational operator. This gives relation between two operands, logical operators, logical and, logical or and logical not, bitwise operators and or, left shift, right shift, negation and XOR. These are the bitwise operator which operates by bit. Assignment operator. These are assignment operators. Ternary operator. This is also called multiple operator. Then we have arrays. Array is a group of similar elements or data items of the same type collected at contiguous memory locations. Arrays are the derived data types in C programming language which can store the primitive type of data such as int, char, double, float, etc. This is the syntax of arrays. Then we have pointer. Pointer is defined as a derived data type that can store address of other C variable or a memory location. We can access and manipulate the data stored in that memory location using pointer. This is the syntax of pointer. Coming to next slide, we have functions. Functions is nothing but block of code which is performing specific operation which can be used repeatedly. Functions can be stored in library and reused. A bigger module is divided into smaller submodule and solved using divide and conquer technique. This is the syntax of functions. Then coming to next slide, in this we have the softwares which are involved in our project. We have used these three software tools: PixSimLab, MPLab, XIDE v5.35, XC8 compiler. Coming to embedded system, categories of embedded system. Stand-alone embedded system. It works itself without requesting a host like a computer or processor. Example: digital camera, refrigerators, washing machines, microwave oven. Real-time embedded system. It is a particular version of embedded system that works on basis of real-time computing represented by a dedicated type of OS. Example: robotics, ATM, GPS system, calculators, radar systems. Then mobile embedded system. It is a small size embedded system that are designed to be portable. Example: wireless sensors, smartphones, smartwatches, medical devices. Network embedded system. It is a embedded system which connect to other device and able to transmit data and receive data. Example: Bluetooth, router, walkie-talkie. Hybrid. It is a embedded system consists of sensors, actuators, plant and control software. Example: automobile, aircraft. Here is the overall components of embedded system. We have microprocessor, memory, FPGA or ASCII, diagnostic port, human interface, ADC, DAC, actuators, sensors, auxiliary system. Coming to memory. Memory is divided into three types: RAM, ROM and hybrid memory. In this, RAM is volatile memory. RAM is further divided into dynamic RAM and static RAM. Dynamic RAM has more power compared to static power, and static power has constant power and it has more cost, and DRAM has less cost as compared to static ROM. Then ROM is a volatile memory. ROM is a non-volatile memory. It can further divide into EEPROM, PROM, masked. In EEPROM, we can read infinite number of times and write multiple times. If we want to override, UV rays are passed through memory. Then PROM is also called as OTP, one memory. Writing can be done only once. Reading can be done infinite number of times. Example: micro oven, mobiles, etc. Next, masked memory. It is particular part of memory will be covered protected layer. Data stored will get computed. Example, manufacturing of data chips, etc. Hybrid memory is both combination of RAM and ROM, and it is further divided into NVRAM, EEPROM and flash memory. Flash memory is further divided into NOR flash and NAND flash. This NOR flash can be used or accessed only byte, and NAND flash is used for accessing of block memory. EEPROM is a non-volatile. It has persistence memory. Reading can be done infinite number of times, and writing can be done in million number of times. It can be byte accessible. Then coming to next slide. Flash memory. As we discussed earlier, there are two types of flash memories, NAND and NOR flash. Sensors are used to sense physical bodies or physical objects. Sensors are further classified into two types, analog sensors and digital sensors. Then we have actuators. Actuators are nothing but, in embedded system we use ICs and semiconductor. Actuators are nothing but which will convert electrical energy into mechanical energy. Further, actuators are also divided into two types, analog actuators and digital actuators. Then coming to next slide, we have interrupts. An interrupt is a signal to the process emitted by hardware or software indicating an event that needs to immediate attention. Whenever an interrupt occurs, the controller completes the execution of the current instruction and starts the execution of an interrupt service routine, ISR. ISR tells the processor or controller what to do when the interrupt occurs. Then coming to microcontroller. Microcontroller is an integrator IC or integrator circuit which can be programmable to perform a specific task. Instructions in designing microcontrollers: memory size, input output capabilities, peripheral function. We have two types of architectures for designing the microcontroller. They are von Neumann architecture. In this, data and code are stored in same memory so that single bus is used to fetch. Hardware architecture. In this, data and code are stored in separate memory so that separate buses are used to fetch data and code. Here is the
Hello everyone, my name is S.Lahari Vishista, currently pursuing B.Tech final year in Electronics and Communication domain from RJKT Basar. So now we'll discuss about our main microcontroller. In this internship, in this project, we'll use the microcontroller P1C16F877A. It is the microcontroller that has 5 ports and it follows hardware architecture. This gives the efficient processing, and also this is the microcontroller which is the automatic which runs the automatic functions. As we are developing the washing machine simulation, this microcontroller is most efficient and effective for our design. Now we'll come across the project. Now coming to our project, we have written the code in MPLAB XIDE. This is the folder which we have generated for the project, and in this it consists of various header files and the source files. In this we have written our code. These are the different various header files, and these are the corresponding codes which we have developed for the digital keypad, timers and a main file. And here we can observe that a file has been automatically generated where it consists all the information of the code. This we need to build a project. For this we'll type production, clean and build project. It is cleaned successfully and it is going to build. Sorry, somewhere I missed. Now we need to build our project. This is the washing machine. Clean and build project. It is cleaned successfully and is going to build. Take some seconds. Here we can observe it is built successfully. After this build successful, we'll get a .hex file where we need to dump that .hex files into our PixSim lab. So we'll go to our PixSim lab. So this is our PixSim lab. First we need to dump our hex file. See, here we have generated a hex file. Open. And then we need to select our board. Here we use our board, PickGenius board, and the microcontroller, as we have discussed, PIC7, PIC I6, P1C16F877A. So here it consists of 16x4 LCD display, and the segments, these are the 16 switch, and these are the 16 switches, and these are the LED segments, and these are the corresponding LEDs, and it consists of 5 ports. So in this we're going to see the levels of washing machine. There are 3 types of levels, also we can include 4. The first is type of washing clothes, the water level, and the timing unit. The first level itself is the start level, in which we'll start our washing machine. For this we need to press these are the switches. This is the RB0, RB1, RB2, RB3, RB4 and RB5. These are the switches where we'll use mostly in this. This is the switch where first we need to reset. It has been reset. Then we need to start our washing machine. 1 second, we'll reset. Now we'll go with our PixSim lab. We first reset, and we need to power on. For this power on, we'll press the switch. It is power on. In order to display the levels, here we got the levels, the washing machine program, whether it is daily, heavy. This switch is used to navigate heavy, delicates, whites, stain wash. By pressing this switch by doing it long press, we'll be able to select this long press. Now it is white. It will select white. After selecting white, it will ask the water level. The water level which we have given is auto, low and medium. We also need to press long. We also need to do long press in order to select. It will display switch 5 for start and switch 6 for stop. In order to start the washing machine, we first press start, long press. This will start the washing machine. See, our washing machine has been started. It is started. If you wanted to do any pause, if you wanted to break, or if you wanted to add extra clothes, we can pause by pressing the switch 6. 6 it is paused. Again if we press, again if we start, after pressing the auto, it will ask the level, and the level if we choose made low, water level. Okay. And we'll start. The washing machine has been started. Now we have generated for daily. In middle, if we open the door, then it will give the buzzer sound and it will prompt the message as door is opened. Once we'll check it. The switch one is for door. See, the door is open. Seconds. At 32 seconds we have opened the door. Again at 32, from 32 seconds it will be running. So this is the explanation of our project. Thank you. This is how we generated the washing machine simulation using MPXC simulator and the PixSim lab. Thank you. Thank you Emertxe.